We are in part 4b where we're looking at, again, graphing parabolas, but this time we are doing inequalities. So we need to be able to shade above or below and choose a dotted or solid line with each of them. One thing you'll notice right away is they're a little bit easier in that all the problems have a 1 in front of the x squared, so our general rule for drawing a parabola will apply to all of these. So let's go to our first one. We're going to do the same thing we do when we're graphing a standard parabola when it's an equation, and we're going to say x equals our negative b over 2a, which means that on this first one, our b is our term next to x, and then our a is, in this case, a 1 out front next to x squared. So we have negative 6 over 2 times 1. So positive 6 over 2, 6 over 2 is going to be 3. So x is going to be 3. So our line of symmetry right here may not be a great idea to actually draw that dashed line there just because of the fact that we might have a solid or dashed line on our graph. So we might not want to confuse that. So maybe just put a little dot here to remind us it's 3. Plug that 3 back into the original equation now. So we have 3 squared minus 6 times 3 plus 12. Now we have 3 squared is 9, 6 times 3 is 18, so minus 18 plus 12. And if we add those all together, our y value is going to be positive 3 as well. So we actually have the point 3, 3 here. Now again, we look at our numbers out front. It's a positive 1, so that means our rule of going 1 over up 1 squared, back 1 up 1 squared applies. Over 2 up 2 squared, which means up 4. Over 2 up 2 squared, which is 4 again. We see that it's symmetrical along this x equals 3 line. And before I draw it, I need to look at my symbol here and decide how I'm going to do my shading and how I'm going to do my lines. For my line, because I don't have greater than or equal to, it's just greater than, it's going to be a dash line. So draw myself a dash line here. And then finally with my solid or dash, I look if y is bigger than this parabola or y is smaller than. Since y is bigger than the parabola, I shade above the line of the parabola. So I shade up here. And that is all there is to it. So let's try one more. It's a little bit different here. If we had to pick one, let's try number 4. Number 4, we're going to start with x equals negative b over 2a, get that vertex right away. And in this case, negative b, well, b is 4, so negative 4 over 2a. And a is 1, so over 2 times 1, giving us negative 2. So negative 4 divided by 2, negative 2. So I'm looking somewhere along this line right here. And I take that negative 2 and I plug it back into my equation. I'm always careful to use parentheses when I plug it back in, especially with the squared term, whenever I have a negative. And so negative 2 squared is a positive 4. 4 times negative 2 is a negative 8, and then plus 1. So 5 minus 8, that's a negative 3. So our vertex is going to be over or back 2, down 3 right there. That's our vertex. Now, standard rules apply because we have a 1 out front. Over 1, up 1. Over 2, up 2 squared, which is 4. Back 1, up 1. Back 2, up 2 squared. If you're wondering where that rule comes from, by the way, it's the fact that this is an x squared term that's causing that. So that's why it's whatever you do to x, you square it and do that to y. So we have our basic shape of our parabola. Now we look at our symbol here. It is less than or equal to, and that means that we do not have dash line. We have a solid line. So trace in our solid line graph here over our dots. And then finally shading. It says y is less than, so y is smaller than the parabola, which means we shade below the line. And you'll see that I can shade out here as well because my line actually does continue. If I were to draw farther up the page, it continues something like that all the way up forever. So I could keep shading all over here, but obviously that's a little bit unreasonable. So this would be a good example. Now finish those last three and you should be good to go.